as Warren said, in the context of a subtask of work package 6. And in this subtask, we are focusing on the potential hazard posed by the presence of naturally occurring radioactive materials in geothermal installations. And we are approaching this from a multidisciplinary perspective. So focusing both on the technical aspects that this brings, but also the societal aspects. This is a short outline of the presentation, which we aim to take about half an hour, more or less. So I will provide a short introduction to, well, the case of geothermal energy, particularly focusing on potential advantages, but also challenges, among which radiation, and then focusing on our research focus of studying radiation and geothermal installation through a multidisciplinary lens. After that, Linde will take over to introduce you a bit more the different systems within geothermal energy production and also where potential naturally occurring radioactive materials can accumulate in these installations. After which we will present our methods, which are both technically oriented and social scientific oriented, and then the results coming to a conclusion in about half an hour from now. And of course, after that, there's ample room, I've been told, for questions or any discussion. So if you have any urging things you want to discuss with us, we will still be here until the end of the seminar, of course. So as a short introduction, well, I am assuming that all of you are at least a bit aware of geothermal energy production, but well, maybe to those who are not, in its most simple form, what does geothermal energy production mean? It means that you use the energy, the heat from the entrails of the Earth, which is there through radioactive decay of elements in the subsurface, and the remaining heat from actually, well, the origins of our planet. And you use this for direct heating or for electricity production. At the moment, on a global scale, geothermal energy production is rather marginal. So here you see, for Europe at least, the number of, or the percentages of renewable energy production in electricity production, and for geothermal energy production, this is less than 1%. Some countries have a bit more, some have a bit less, but it is rather marginal. It is used a bit more for direct heating, but still it's not something that we are all very familiar with at the moment in our energy production means, let's say. However, there are those who are expecting that actually this might change in the future and that geothermal energy production might take a more significant position in future energy matrices. Because of different advantages that are being connected to geothermal energy production. First of all, there is an emphasis on that it's renewable energy. So renewable in a sense that, well, the amount of heat that you extract from the Earth is minimal versus the theoretical output that is being generated by this radioactive decay and the remaining heat from the origins of our planet. Also, the heat extraction, which happens through extracting water from the subsurface, is often coupled to also re-injecting this water back into the subsurface. So in that sense, it's also renewable. It provides a baseload energy source, meaning that in contrast to, for example, wind energy and solar energy are not dependent on weather conditions. It is there, at least in theory, in abundance all the time. And it has a relatively small footprint in terms of land use. So in contrast to some other energy production means, the impact on the landscape itself is rather minimal on the surface. Of course, there's also potential challenges which might hinder the full deployment of geothermal energy production and which might have hindered it also already in the past. And probably the most important one here is the site specificity and the connected financial risk that comes with this. Meaning that while in theory, geothermal energy is abundant, in practice, it means that to reach the sufficient depth and to actually be able to extract heated water and also extract the heat from the water, this is probably limited to a couple of sites, and the best way of knowing whether you can actually do this in an efficient and effective way is by building an installation. So this means that there is a certain financial risk in the sense that you might be building an installation that in the end is not as efficient or not as effective as you might have expected. So that means that there is, for investments, financial risk to take into account. And then more, let's say, in terms of the surroundings and the impact on the surroundings, what is known already from the past is that geothermal energy production can cause seismicity. So by pumping up water, but by also pumping it back down under high pressure, you might be inducing seismicity, which is not very high necessarily on the scale of Richter, but which might be felt in the surroundings of a geothermal installation. Then there's a general issue of potential environmental pollution. So you're pumping up water to extract the heat, but with pumping up water, you're also pumping up other materials gas, heavy metals, other potentially harmful materials, which if not managed well, or if there is a malfunctioning of the installation, might also spill into the environment and hence as a consequence having environmental pollution. And of course, this is the focus of the presentation today as one potential attention point with this idea of pumping up more than just water, but also other potential elements. There is the possibility that you're pumping up also naturally occurring radioactive materials which can accumulate in your installation. And this is what Linde will talk about in more detail in a minute. So what we aim to do in our study on which we are presenting here today is we aimed to better understand this potential presence of naturally occurring radioactive materials in geothermal installations, both from a technical perspective, so focusing on the hazard, to what extent are naturally occurring radioactive materials indeed present in installations, and what kind of volumes with potential, what kind of potential levels of radiation, but also focusing on putting this hazard in its social context, let's say. So how is this hazard perceived as a risk or not by relevant stakeholders? How is it being managed? How is it also communicated about? So this needs a multidisciplinary approach which combines insights from various scientific disciplines. As a central research question, we then aim to answer the question of what potential hazard is posed by natural radioactivity in geothermal installations, and how are the risks related to this hazard perceived, managed, and communicated about by stakeholders. In our study now, we focused on professional stakeholders, so actually people working in geothermal installations, managing geothermal plants, or working in what we call supporting industries, so working in research, in radiation protection, in the regulatory activities that come with managing the potential presence of natural radiation in geothermal installations. It is, as far as we know, kind of a first of its kind study because it combines not only insights from the technical research and kind of characterizing the materials in these installations, but also focusing on this risk perception, risk management, and communication aspects that come with it. So and now I will give the word to Linde to talk a bit more about geothermal energy.
Thank you, Robbe. So actually, geothermal heat has already been used since ancient Rome. Warm water that came to the surface was used for cleaning, household, and other things. Now we are more looking at the industrial application of geothermal heat, knowing also that there are geothermal pumps that are used in single households. So here we are focusing on the industry, and actually 3 different types of plants can be distinguished from each other, depending actually on the heat of the temperature of the water that is pumped up from underground. You can also see a map on of actually Europe where the geothermal plants are producing or heat, for example, for district heating or greenhouses. But also the production of electricity. The electricity production actually needs very hot water, more than 235 degrees Celsius, and it's often found in depth larger than 4 kilometers. So that is already some drilling. But then, of course, also there are flash steam cycle plants that can be used when the water has a temperature from 150 degrees. But then also binary cycle power plants that can function with lower temperatures, and here it is this type of plants is used, for example, the district heating or cooling of the district heating or cooling or the heating of greenhouses. Very simple. This is a schematic overview of how such a geothermal plant is working. So hot water is pumped from the surface, is going to the degasser where the gas that is pumped up with the water is separated. The hot water is then going through filters to the heat exchanger, where of course the heat is transferred to a secondary circuit. This secondary circuit can be or the district housing or greenhouses, or for example, when you have much higher temperatures, also the turbines, for example, steam, where the electricity can be generated. The cold water afterwards is then re-injected to the reservoir again, actually making a cycle and being as less pollutant as possible. But of course, with the pumping up of that water, and such as what Robbe also said, other things are also pumped up, there can be some things that are left behind in the installation itself. For example, on the left, you can see the inside of a degasser when the water is drained during the maintenance and the cleaning, and you can see that there is a sludge left behind. Or for example, there is also some material that scales in the pipelines due to changing temperature or pressure conditions. And of course, these filters that I was talking about also need to be changed regularly. And currently they are only disposed on landfills. So of course, that is not very favorable. For this, for the technical part of this research, I collaborated together with a geothermal power plant from the Netherlands, which was a type of the binary cycle power plant. And they actually provided me with some samples, and the first was such a sludge sample from in the degasser, also a sample from the pipeline before the filter, and also filling from in the filters itself. I characterized these samples with gamma ray spectrometry and XRF. Mainly the XRF was used to correct the gamma ray spectrometry samples for internal attenuation.
So, as said, we didn't only aim to understand the hazard itself, so the presence of these materials and aiming to characterize these, but we also aim to understand how relevant stakeholders, and here the professional stakeholders, are actually looking at this hazard. So what kind of risk they are perceiving to this and how they are managing this risk. And to get better insight into risk perception and risk management, we conducted two social scientific methods. Qualitative methods. First and foremost, we used semi-structured interviews with 8 different respondents from the Netherlands and Belgium, talking with them about, well, how do they perceive this risk? How do they perceive potential other risk related to the geothermal installations? How are they managing it? What kind of room for improvement could there be? These interviews were conducted about a year and a half ago and lasted more or less than 1 hour each. And secondly, we conducted also a workshop in which we invited the same stakeholder group and to which we were successful in gathering more than 20 participants to discuss with us during half a day, well, how are they actually thinking about this radiation risk during the operation of geothermal plants, also in terms of the waste management and the risk that this brings, and then how do they think that they can communicate with stakeholders about this risk and engage them maybe in also the management of this risk. This happened during summer of 2023. We all didn't only aim to understand risk perception and risk management, but also risk communication. So how is this risk actually already communicated about nowadays? So first of all, we focused on the presence in the public discourse regarding this risk. And there we focused on Belgian newspapers and social media in Belgium in the past 10 years. So we looked at to what extent is this risk already being talked about in the public discourse in these media? And then we did a targeted search for the available information on this risk on the websites of relevant actors. So the geothermal energy plants themselves in Belgium and in the Netherlands, but also the websites of authorities and other stakeholders in the vicinity of geothermal plants to kind of see to what extent they are discussing and in which ways they are discussing this radiation risk.
So with the gamma ray spectrometry of the samples, these results came out. First, I have to note you all that the axis of the specific activity is in logarithmic scale. So also that actually the lead-210 content is of course much higher than all the other radionuclides. Seeing from the analysis of these samples, the content of all the radionuclides remain under exempt limit So this can be seen as actually normal waste and does not have to be treated and will not fall under the regulation of radioactive waste. For the rest, I have to also say that this is one site that was, samples of one geothermal site are analyzed. And so this gives more information on what is found within that site, but other sites over the whole world, also over the Netherlands, they can have other results. But then also, for example, the XRF results, they show that these samples mostly are made of silicium and aluminium, also some iron, sodium, and calcium. I also looked at the rare earth elements and the very toxic elements, rare earth elements such as yttrium and neodymium, but then also the toxic elements such as arsenic. And these elements were all present also, I found in these samples, and they were found in concentrations of about 2 parts per billion. So both rare earth elements and toxic elements are in very, very, very low concentrations present in these samples, which is also a very good thing.
Okay, so with that, we knew about, well, the presence of certain elements and also certain naturally occurring radioactive materials in these or in this particular installation, but we also wanted to know, well, how is this potential hazard then being perceived by the people working in these plants or working in similar plants or working in the supporting industries? And for that, we started with focus on risk perception. First of all, we noticed that actually these stakeholders, they perceive various risks when it comes to managing a geothermal energy plant. Some of them you can classify as traditional industrial risks. So it's working in industrial sites, which brings risks of fire, of working on heights, of having malfunctioning of certain instruments, etc. These are traditional industrial risks. They also talked a lot about seismicity risk. So this idea that actually by retracting or by taking water out of the earth and pumping it back under high pressure, you might induce seismicity in the surroundings. And then obviously also radiation risk was actually recognized by all of our respondents as a potential risk when it comes to exploiting a geothermal energy plant. And for some, it was the main risk that they perceived. For others, it was one among these many different risks. In general, there's two main contexts that people recognize to which this risk really emerges. Most of them actually stated that, well, when a plant is operating as it should and it's closed, so there's nothing really happening except the heat extraction which is going on, actually there is no risk to them. They consider then that, well, the system is closed and there can't really escape anything, let's say. The main context in which there is a risk that they are aware of and need to manage, it is when the plant is opened up for maintenance. So when, as Linde says, filters need to be taken out or when parts of the installation need to be replaced, that's the moment in which people recognize, okay, now radiation risk is something that we need to be aware of and that we need to manage in a good way. The other context, which was less often discussed in the workshop, but also especially in the interviews, is during waste management. So it's basically when you're taking out these materials and you need to remove them from the plant and you need to do something with them. Of course, also there, the handling of these materials themselves after their removal can bring a certain need for precautions, let's say. So also there, the radiation risk is perceived as being present and needing sufficient management. Well, significant, our respondents all considered, and I think this is also in line with the technical findings that we have, that the radiation risk is maybe rather minor. Minor in terms of probability, because it is site-specific. So in some sites, well, there is very little materials actually remaining in the plants, which can be classified as naturally occurring radioactive materials. And is also limited to specific phases of operation. So at the end of, let's say, the cycle, when the waste is being removed in the waste management and during the maintenance of the plant. So when the plant is just operating as it should and when it's closed, the probability was considered to be very unlikely that you would expose yourself to radiation. In terms of consequences also there, because these are very low doses that people considered, They also considered this to be a statistical rather than a catastrophic risk, meaning that, well, they did not consider that they would expose themselves to any kind of dose which would have any kind of immediate effect. We're not talking about inducing radiation sickness, for example, but we're talking about a statistical potential risk for your health on the longer term, which also meant that people considered to be a rather minor risk. And then there's the issue of controllability. So people recognize that, okay, yeah, we might be faced with this risk, but we can also control it in different ways and in good ways because we have protective measures, we have protocols, etc. And I will talk about this more when I come to the risk management. Although it was perceived as maybe a rather minor risk in general, there was, however, by all of the respondents that we talked to, also perceived need for continuous attention to the risk and good management of the risk. And this for several reasons. First of all, because it was recognized that actually this radiation risk has a dynamic character of itself, meaning that, well, as I said, it's site specific. So because on one side you might not really have this issue, this does not mean that at another side you will not be faced with it. So this is really also a recognized need among the people that we talk to for continuous and higher numbers of characterization studies in each site, which could be used for geothermal energy production. But also it is dynamic in time. So people recognize that although they might not be really pumping up high volumes of certain elements at this moment in time, when other parts of the water reservoirs that they're using might be pumped up, these kind of issues might be there. So this is also a need for continuous measurement and continuous characterization, not just one moment in time, but also over time. There's also the dynamic character of the industry itself, which has been recognized. So in many countries, including Belgium and the Netherlands, where we gathered our data, geothermal energy production is considered as rather novel and new industry, which is only forming. And it was recognized by our respondents that this also comes with a learning curve. So while they recognize that they already did quite some learning now over the past years, there's still quite some things to be learned from other industries. So people often refer to the gas industry and the oil industry, which especially in the Netherlands is much more established also in terms of the risk management that comes with potentially naturally occurring radioactive materials. So in terms of the protocols, the procedures, and the ways of handling this risk, there was often reference made to a learning curve, which still needs to be climbed as well for the geothermal industry. And then there is also the potential perceptions of others, which make it important that you have continuous attention for the radiation risk in geothermal plants. Because although our respondents might consider it to be a rather minor risk in their daily operations, let's say, they're also aware that for others, and particularly here referring to citizens living in the vicinity of the installations who might hear about the potential presence of radiation, they might not perceive it as such a minor risk. So this means that they also need to show that they care about this risk, that they are aware of the risk, and that they are taking sufficient action in managing it. So these were all considered as main reasons by our response for saying, well, look, although it might be minor, it's not something that we can just neglect. It is something which is important to us and that we need to have continuous attention to. And this also then is shown in the risk management that people share with us. So it was considered that, as I said, the risk is controllable, and this controllability is showing itself in different risk management strategies which are currently being used. So at the company level, different measures are being taken. It's about using protective clothing, about continuous measurements with dosimeters, medical follow-up, having in general a good safety culture. Those are considered to be main important issues, especially during this context of opening up your plant and in waste management, that the company actually needs to make sure that this management is conducted in a safe way. At the sectoral level, mostly it was considered that the sector needs to provide good protocols and ways of harmonizing the ways of handling radiation risk. Because again, it is a new sector in especially here Belgium and the Netherlands, but also in many other countries. This means that there's still people looking at each other to kind of see how are you doing this and learning from each other from good practices, but also potentially challenging experience that they had in the past. The main responsibility for good risk management is being put with the operator. So the operator, according to our respondents, need to be first and foremost aware that this risk might be there. They need to characterize this risk, hence needing the work also of people like Linde and others to characterize the technical risk, let's say. They need to provide protective measures and follow the rules that are being set by the regulator. They also need to train their workers internally, but also externally, who come to site for maintenance and waste management, for example, on how to handle this risk. However, there was also a shared responsibility recognized for the sector and the regulator more generally in terms that they need to provide guidance, monitoring, and follow-up on how to manage this risk. Most interestingly, probably, is that there was also room for improvement or potential improvement recognized by our respondents. So in terms of safety culture, although most of the respondents that we talked to who are actually working in geothermal plants stated that they considered that their safety culture is actually up to date and that they are doing all they can and maybe probably even more than they should in terms of managing this risk. When we talked with people more in the supporting sectors, people in radiation protection, etc., they also referred to examples that they heard of or that they encountered themselves in which a safety culture was maybe just rather mediocre or even underperforming sometimes because people adhere too much to what they knew already before and are not adhering to any kind of new knowledge that comes up with regard to managing radiation risk. So there was considered mostly by the supporting sectors that there was room for improving the safety culture by providing more training, by making sure that people adhere to good practices rather than what they are used to do in past employments, let's say. For waste management, it was, as Linde said, recognized that currently when it comes to managing the materials that come out of geothermal plants, most of these are considered to be, directly in a linear way going to landfills, like let's say permanent disposal. And also there was recognized that maybe we could look for other ways of managing these wastes, thinking more about durability or sustainability and circular economy. Maybe we could extract some rare earth elements from these wastes, for example. Maybe we could recycle parts of these waste. This was considered as a better way of managing also the risks that can come with these waste if they are just permanently disposed. One of the main side remarks that was made here is that at the moment, because of the small scale of the geothermal energy sector and hence also the small rate of volumes that are being generated in terms of waste, relatively speaking, the business case for these alternative strategies might not be there yet and maybe might not even come at any point because this would require specific infrastructures, specific investments to be made in order to actually handle these wastes beyond just final disposal. So that was something to take into account. Then looking at risk communication, first of all, looking just at the presence of this topic in, let's say, public discourse in Belgium, we can be rather short and say that over the past 10 years, we did really find very little encounters in which this risk was actually discussed in public discourse. So when you look at newspapers, only 2 articles actually over the past 10 years specifically talk about the potential presence of natural radioactivity in geothermal installations. In many other cases, there was no mention of this, or it was more in terms of the potential seismicity risk that comes with geothermal installations and the risk that this might pose, for example, to nuclear installations in the vicinity, so not having anything to do with naturally occurring radioactive materials. Basically a bit of the same picture on social media. So also there, over a 10-year period, we only found a handful of social media posts which are actually talking about this risk. This does not mean that information is not available. So when we did then a targeted media or targeted information search for information on this risk on the websites of geothermal plant owners or the websites of authorities, focusing here particularly on the Belgian project, we saw actually this information is available. However, it requires a dedicated search. So you already need to be aware of this information. It is not likely that you will stumble by coincidence on it because it's on a subpage of the web page or a subpage of the subpage. So it requires a dedicated search. And this opens up a bit of reflection on, well, what do we need to do with this communication? Taking into account, the characterization study that Linde has done, taking into account that these characterization studies need to be repeated in other contexts as well, or in other sites as well, taking into account the risk perception, and it's considered a rather small risk. To what extent should we proactively communicate about this risk, let's say also to the broader public or not? That's one of the things that we were faced also with in our research, and it was also discussed during the workshop, for example. And what we think as researchers, but we can discuss this also, of course, now after we finish the presentation, is that probably we should go for a graded approach, meaning that the more you're in, let's say, really the physical vicinity of an installation, meaning that you work there, that you need to do operations there, or that you live in the close vicinity, or that you live farther away and are just a member of the general public, the more information needs to be proactively provided on this, because we also don't want to necessarily provide very proactive information in broad public communication campaigns, as this might actually over-exaggerate the actual risk which is there and might pose more fear in people than actually might be needed. So this graded approach, according to us, is probably the best way to go.
So to conclude, this multidisciplinary approach to radiation risk is, to our knowledge, the first of its kind, where we both look at the technical and the societal aspects of radiation risk within the geothermal industry. I still have to say that every geothermal installation is unique, and thus also every geothermal installation, the radiation risk in every geothermal installation is different and needs to be monitored and needs to be characterized. When we are looking at the awareness between the workers and the public, we see that the workers are very aware of the potential risk, and also that it is known by the stakeholders. There is a really great safety culture within the industry itself, by the workers, by the stakeholders. But on the other hand, there is hardly any communication to the public. This meaning if it is needed or not, but I think it is, although it is very needed, that that there should also be some societal research of the public, and that the public needs to be interviewed on their point of view of this type of risk within the geothermal industry that is there, or if they think it's not there. But also to conclude, we would sincerely thank everybody who participated in this research and everybody who enabled this. Also the ENA and the ERA association, and also the geothermal installation that allowed us to perform some characterization on these residues. So thank you, and if there are any questions.
Great, thank you very much. I'm just going to stop the recording quickly.